Now that we've seen the derivatives of the exponential and logarithmic functions, let's take just a moment to look at their properties and discuss them in terms of their derivatives. So a property of exponential functions, which is well known, is that exponential growth is very fast. And this is because e to the x is its own derivative. So e to the x may not be very large initially, but once it gets large, it grows quickly. If we take a look at this graphically, here's e to the x. It's not initially very giving you, I should say, very large values. When x equals 0, e to the x is 1. And that 1 is also the growth rate. It's growing at a rate of 1. However, e to the x is an increasing function. And as e to the x increases, its growth rate increases. So when x is 1.616, e to the x is 5.033, and it's growing at a rate of 5.0033. When x is 2.076, e to the x is 7.973, and it's growing at a rate of 7.973. So we see this very fast acceleration because as x increases, its growth rate is also increasing. And of course, as its growth rate increases, the exponential function grows faster and faster, and the faster the exponential function grows, the faster its growth rate grows. So the faster the exponential function grows, and these things reinforce each other and give us immensely fast exponential growth. The natural logarithm is kind of the opposite of this. Probably students in a Calc you this class won't make this mistake, but a lot of people who don't really know what a logarithm is seem to think that logarithmic growth is fast. Like I was listening to a podcast and it was talking about the growth of independent tabletop role-playing games. And they were saying that the growth of this industry was logarithmic. And what they were trying to say was that it was growing very fast and whatever. I mean, the point of language is to communicate. I know what they meant. Their listeners know what they meant. It's hardly the end of the world, but you can take a look at the graph of the logarithmic function and tell me for yourselves whether you think this thing is growing quickly. And of course, the reason for this is that the derivative of the natural logarithm is 1 divided by x, and 1 divided by x is getting closer and closer to 0 as x increases. So as x increases, the logarithm is growing more and more slowly. When x is 301, the logarithm is growing at a rate of 1 divided by 301. When the logarithm is 999, when x is 199, the logarithm is growing at a rate of 1 divided by 999. When, when x is 1,000,000, the logarithm is growing at a rate of 1/1,000,000th. When x is 1,000,000,000, the logarithm is growing at a rate of 1/1,000,000th. So the bigger x gets, the slower the logarithm grows, which is why when x is around 1,000,000,000, the natural logarithm is still sitting at 20 point something. So exponential growth is very fast because e to the x is its own derivative. And the bigger e to the x gets, the faster it grows. The logarithm sees the opposite behavior. Its derivative is going to 0. The bigger x gets, the slower the logarithm grows.